All right, welcome to our notes on piecewise functions. So first off, we have to talk about what is a piecewise function. So I'd actually like to start by looking at these two piecewise functions right here. So both of these are piecewise functions. So if you look at them, it's a function, obviously, hence the name, but it's made up of other functions, and then they have restricted domains. So if you look at our book definition, a function represented by a combination of equations, each defined by a specific domain. So just to explain what this is really quickly. So this is the line y equals, or f of x equals 1/2 x plus 4, but we're only graphing that for x values less than -2. All right, so the domain's restricted there. And then the same idea here, this is the line y equals, or f of x equals -3/2 x minus 2, but we're restricted to this domain. We're only graphing that for x values greater than or equal to -2. So that's an example of what a piecewise function looks like. Before we graph, let's go ahead and evaluate a piecewise function. So here's our piecewise function. F of x equals, and then we have this piece. Oops, that's an eraser. We have this piece right here. F of x equals x minus 4, and then we have f of x equals 3x minus 1. So this says evaluate f of x when x is -3, and then separately do x is -1. Now remember, because this is a function, when we plug in -3, we only get one output. So we have to decide, are we plugging into this equation or are we plugging into this equation? Which one are we plugging it into? So what we're gonna do is we're gonna look at the domain restriction. So we're gonna ask ourselves, is -3 less than -1, or is -3 greater than or equal to -1? Well, -3 is less than -1. And because -3 is less than -1, we are going to plug it into this equation here. So we're going to plug it into f of x equals x minus 4. So now we can evaluate that. We can find f of -3 by plugging in -3 there. So -3 minus 4, and we get f of -3 is equal to -7. And you can just box the -7 because that's the output, or you'll sometimes see me box this because it's super proper, you know, f of -3 equals -7. It's saying us when we plugged in -3, we got -7. It's also saying the point, -3, -7, is on this function. All right, same idea for the next one. It says find x, when x is -1, what's the output? So, is -1 less than -1? Nope. Is -1 greater than or equal to -1? Yes. So since -1 is greater than or equal to, it's actually equal to, we're going to use the equation f of x equals 3x minus 1. So to find f of -1, we're doing 3 times -1 minus 1, which is -4. So we have f of -1 is equal to -4. Or you could just box -4. Good? Okay, let's move on to graphing. Okay, so there's multiple ways that I can teach you how to graph a piecewise function. You kind of adapt to whatever you're given. Because sometimes you'll say like, oh, this is a line. I know what that looks like. I can graph from here, right? Sometimes it's a quadratic and I gotta think about what this looks like. But if you have if you know, okay, here's the vertex and it goes this direction, this way, and this over here, then you just adapt, okay? We adapt. But I'm gonna show you how a foolproof way of doing it every time. So I'm gonna start by graphing this line right here. Y equals, or f of x equals 1/2 x plus 4. And I'm gonna graph this one in blue, okay? So I only wanna graph it for x values less than -2. So could I graph this entire line and then bust out my eraser and erase everything that's less than -2? Yeah, but that seems like something I don't want to do because it's more work. So what I'm going to do is I'm going to start graphing it at the x value of -2. So I need to know -2 comma what is the point where it air quotes starts, because really there's nothing there, so I'm going to put an open point there, a hole there. All right, so let's see what we have. I'm going to plug -2 into this equation here. So I have 1/2 times -2. I'll write down this first couple times what I'm doing, but I'm just going to say the math out loud and do it mentally. So 1/2 times -2 is -1 plus 4 is 3. So I know that there's an open point at -2, 3. I'm going to make my open point right there. Okay. All right, so now I have an option. I know that the slope is 1/2, so I can graph x values less than 2 at the slope of 1/2, or I can continue to plug in points less than -2, which I'll start by doing, and then you'll see, oh yeah, that's the slope, okay? So I'll do the foolproof way first. So I plugged in -2, now I'm gonna plug in -3. If I plug in -3 here instead, doop, like that, I get -3/2 or -1.5 plus 4 is 2.5. So now I have -3, comma, 2.5. -3, comma, 2.5 is right there, okay? And now if I keep going, if I plug in -4, -4 times 1/2 is -2 plus 4 is 2, right? And then I get this pattern like this. I'll make that a little better right there. Like this is, there we go. So there's my points right there. So now I had a little bit more points than I would actually prefer. So what I was saying before is that you could have just used the slope of 1/2 to say, like, I'm gonna go down 1 and left 2 to get this point, down 1 and left 2 to get this point right here, right? And get the rest of your points. It's just that you don't wanna say my slope is 1/2, I'm gonna go up 1, right 2, up 1, right 2, because you're not graphing values to the right of -2, yeah? Okay, let's go ahead and graph the next piece right here. So I am only graphing values greater than or equal to -2, so I need to know where that point is. So I'm gonna say -2, plug -2 into this equation. -3/2 times -2, so -3 times -2 is +6, divided by 2 is 3, and then 3 minus 2 is 1. So I have the point -2, 1, which is right here. And then once again, you can use your slope or you can keep plugging in values. So I'll plug in 0 next, and I get -2, right? And then I can see this right here. I go, oh yeah, my slope, it's down 3, right 2, down 3, right 2. And then I can make that piece right there. And it goes forever and ever, x values greater than or equal to -2. And there's your piecewise function. All right, now we're asking you for your domain and range also. So domain looking left to right, this starts at an arrow, and then there's x values here, 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 and then some people accidentally say it stops and there's no x values here. So they'll say like no x values at -2, but there are x values at -2 right here, so it keeps going, 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 going forever. So your domain is all real numbers. You're not excluding you're not excluding -2 from your domain. There is a value at -2. Negative infinity to positive infinity, okay? My range, there's an arrow pointing downward that goes forever and ever, negative infinity. And then if I look up this way, there's y values here, there's y values here, there's y values here, and then all of a sudden my y values stop there. There's nothing above that. So my y values stop at that y value of 3. And there is a value there, so I'm gonna use a bracket on it. Yeah? All right, let's go ahead and try this next piecewise function. So we are gonna start with this first piece right here, which is a parabola, but I'm only graphing values less than or equal to 1. So I'm gonna find out where that point is, 1 comma something. Plug 1 in there and you get 1 squared is 1. So I have a closed point because of greater than or equal to at 1, 1. All right, now I'm only plugging in values less than 1. So I'll plug in 0. When I plug in 0, I get 0. I'll plug in -1. When I plug in -1, I get +1. I'll plug in -2, I get +4. And you can see your part of your parabola starting to form here. You always want to plug in at the very least 3 points to see where that vertex is and the curve is on your parabola, because 2 points aren't enough to make a parabola. 2 points are enough to make a line, but not anything else. So I was trying to get that curve going there. All right, there's that first piece. All right, now I'm going to make the second piece right here. So this piece right here, we're only graphing values between 1 and 4. So it's going to have 2 endpoints. So I need to know where the one of 1 is at, and I need to know the one that of the point at 4 is at. 4 comma what? So let's plug in 1. The square root of 1 is 1. And then plug in 4. The square root of 4 is 2. So I have an open point at 1, 1, but there's already a closed point there. So I'm not going to open it up. It's closed. And then an open point at 4, 2. So right 4 up 2. There's my open point. And then remember, this is a square root function, which is a curved function that usually looks like this, right? But I'm only graphing it between that closed point and this open point. So I'm going to graph it, and I'm trying to make sure it doesn't look like a straight line there. There you go. So there's your piecewise function, and now we can state the domain of this. So looking left to right, I have an arrow pointing to the left forever, so that's negative infinity. And then my values stop at 5. Did I graph that wrong? 4, 2. Right? 1, 2, 3, 4, up 2. Yeah, I graphed it wrong. So I was going to get my domain wrong, but then I thought. Isn't that exciting that I thought? All right, so write 4, be able to count to 4, because I couldn't. Sorry about that. Write 1, 2, 3, 4, up 2. There's my point. I accidentally graphed it at 5, too. And then there's that curve right there. Okay, so going back to my domain, it is negative infinity to 4 with no point there, so I'm going to put a parentheses on it. And then my range, the lowest my graph goes is 0. Put a bracket there, but then it goes on forever and ever, so infinitely. All right, let's go ahead and try a few more here. Okay, so this first one right here, I'm going to plug in -1 and see what I get. So when I plug in -1, I get 3. So -1, positive 3, and that's a closed point. Okay. And then I want values to the left of that. So I'm going to plug in -2, and I get 2. And I could also just use the slope and say, oh yeah, the slope's 1. So I need to make a line with a slope of 1, right? And then I have this piece right here. Okay. That was -1, 3. Okay. All right. My next one, only x values in between -1 and 2. So I need to know -1 what and 2 what, so I can make that parabola. It's x squared, so it's parabolic shaped. So I'm going to want to get the points in between there. I'm also going to want to plug in 0 and +1, so I get the right curve to this parabola. All right, so plug in -1. -1 squared is +1 times 2 is 2. So I have -1, 2, and that is an open point. Okay, and then I have plug in 2, and I get 2 squared is 4. 4 times 2 is 8. So I have 2, 8. 1, 2, 3, 4, 5, 6, 7, 8. Oh, the graph paper goes up to that. Right, so I want to make sure that this is supposed to be a parabola in between these 2 points, or part of a parabola. So I want to know, like, does it look like this? Does it dip down like this? Like, what does it look like? So I'm going to get those other points in between. So I'm also going to plug in 0. If I plug in 0, 0 squared times 2 is 0. And if I plug in 1, I get 2. So then I can see, oh yes, that is a parabola with vertex 0, 0 that has a vertical stretch of 2. So that's why it looks like that. All right, my very last piece here, I'm only graphing values greater than 2. So I'm going to have an open point at 2 comma, plug in 2 for x, and I see that there is no x. I have a horizontal line. I have an automatic output of 3. So I have a point at 2, -3. There's a closed point, or sorry, an open point there. And then that is a horizontal line. It's always 3 as an output every time after that, right? All right, so now I want to get my domain and my range, right? So my domain, I'm looking left to right. Okay, when I look left, I see an arrow pointing to the left forever and ever, right? So I'm going to follow this with a highlighter. So here's an arrow here, okay? So there's x values here, there's x values here. And then my x values stop, but then they pick right back up vertically, so they keep going. Still x values here, still x values here. I'm looking at x values even though it feels like I'm going up, right? So I could be going like this. X values here, x values here, x values here, x values here. There's x values here. They don't stop, and they keep going forever and ever. So I have a domain of -infinity to +infinity. My range, the lowest my graph goes, there's an arrow pointing downward, right? There's y values here. There's a hole right here. But guess what? There's y values here. There's y values here. There's y values here. Oh, there's a hole right here. Well, there's still y values there, right? Like here and here. There's y values here, here, here. And then all of a sudden they stop right there. So my y values stop at 8. Let me get rid of all this crazy highlighting. So -infinity to 8, and then there's a bracket on that answer because there is a point at 2, 8. All right, the next one here, I have an absolute value function, so this can be V-shaped, and then k of x equals 4 or y equals 4, so that's a horizontal line. So I'm going to start with the absolute value, okay? You could start off by saying like, okay, the vertex of this absolute value, right, this is moved right to up 0, so the vertex is at 2, 0, and then it's V-shaped, so it looks like this, and I'm only graphing up to 4, so I'm stopping here, but I'm going forever in this direction. So you could start it off by saying like, I know what this looks like, I'm only graphing a part of it, and just making sure you only graph those parts, okay? Or you can plug in 4 and see what that point is, right? So plug in 4, 4 minus 2 is 2, the absolute value of 2 is 2. So I have a closed point at 4, 2. Plug in 3. 3 minus 2 is 1. The absolute value of 1 is 1. And I'm going to the left because x value is less than 4. And then I plug in 2, I get 0. I plug in 1, I get 1. And then there's your V shape. So it's, you know, when I say adapt, like do it, adapt. Do it however you want as long as you're only graphing in that restricted domain and you're not graphing past that restricted domain. All right, horizontal line, I have a x value of 4, the output is 4, so 4, 4, open point, and then there's my horizontal line, like so. All right, my domain, negative infinity to positive infinity. My range, 0 to infinity. Okay, how many do we got left here? Oh, 2 left and then writing. Wonderful. If you'd like to pause the video and try these yourself and then just fast forward through me talking or check in with the answer key, you can try these 2 out here and then come back for the writing equation of, okay? So I'll start with this one the first one, which is a horizontal line, y equals -1, and that's only for x values less than -1. So plug in -1 for x, you get an output of -1. So at -1, -1, I have an open point, and then that's a horizontal line, y equals -1. Okay, my next piece right here, this is a cubic function, y equals x cubed. Remember, a cubic function looks like this, right? There's a point right there. Okay, so if you're like, I want to graph that, and then only graph it from -1 to 1, you can do that, okay? Or you can plug in -1, plug in 0, plug in 1. Right, because we want all the points in between to make sure we don't make a straight line. Plugging in -1, you get -1. -1 cubed is -1. Plugging in 1, you get 1. So I have -1, 1, which is a closed point. So now I'm going to close this point. It was open, now it's closed. If you plug in 0, you get 0, and you plug in 1, you get 1. So it looks like that. All right, and then lastly, I have another horizontal line, y equals 1 or p of x equals 1. It starts at the x value of 1 and gives me an output always of 1, and that's an open point, but if you look, it's already closed. So I'm going to keep it closed and continue off of that, and that's what it looks like. All right, my domain, arrow to an arrow, no gaps, negative infinity to positive infinity. My range, I don't like how it's in green. I can't help myself. I'm sorry, my OCD is hard. All right, negative infinity to positive infinity. And then my range, the lowest my graph goes is -1, and there are values at -1, so we're using a bracket. And then the highest my graph goes is +1, and there are values there, so we're using a bracket. All right, last graphing one. So this one we're graphing the line y equals -x for x values less than 0. And then y equals +x for x values greater than or equal to 0. So I know that I'm going to plug in 0 for x, and I get an output of 0. So at 0, 0, I have an open point, which I just can see that I'm already going to end up closing it, but it's fine. And then this one has a slope of -1, and I'm only graphing values smaller than 0, right? So I'm graphing this direction, and I want a slope of -1. So a slope of -1 would be up and to the left, okay? Or you can say I'm plugging in -1, I get +1. Plugging in -2, I get +2. However you want to do it, okay? And then for this piece right here, I'm plugging in 0 and I get 0. So I have a closed point at 0, 0. So you're just going to close that open point. And then this one has a slope of 1. So up 1, right 1, up 1, right 1, up 1, right 1. Or when you plug in 1, you get 1. So if you look at what this looks like. Did I get crooked here? Is this an uneven graph paper? Ew. I feel like I was doing something wrong. 1, 2, 3, 4, 5, 6. This is a 7 by 1, 2, 3, 4, 5, 6, 7. How come I'm not? What's going on? Oh, it's a 7 by 8. 1, 2, 3, 4, 5, 6, 7, 8. It's a 7 by 8, and this is 8 by 8. What weird graph paper. It must have got cropped. So it looks crooked, but it's because the graph paper is not symmetric. Okay, let's just make sure we realize that. All right, but anyways, our domain, if you look left to right, it's an arrow to an arrow, negative infinity to positive infinity. Let me get my black pen back out. And your range, the lowest it goes is 0, and there is a y value there, and it goes on forever, infinitely. Okay? All right, now I'm going to fix that graph paper before you see it. Was it all like that? Gross. Okay, I just didn't notice the other ones because they weren't symmetric. What function does the graph in number 6 resemble? Why would this be the case? So this resembles, if you look at it, it's V-shaped. It's our absolute value function. And it doesn't just resemble it, it looks exactly like it. So absolute value function. And if you look, it's because y equals negative x for x values less than 0, and y equals x for x values greater than 0 is the same thing as f of x equals or y equals the absolute value of x. It's the same thing. It's saying, give me, that's what you're doing, right? It has a slope of -1. That one has a slope of +1. All right, lastly, we're graphing this piecewise function. So there's 3 pieces. So we're going to have 3 parts, right? And we're going to bring them together with this grouping symbol. So I'll start with this piece right here, okay? You're going to have to write the equation of the line or the parabola or whatever it is, and then also you're going to have to state the domain, okay? So if you look, this is a horizontal line, no slope. It's the horizontal line going through the y value of 1. So that's the line y equals 1, right? And it goes from -5, -1, -2, -3, -4, -5, yes, just making sure, to 0. So we want to write that. So we're going to say you get y equals 1, and that's if your y values are in between -5 and 0. So we're not going to write an interval notation for piecewise functions. Notice they've all been an inequality notation here. So we're going to say in between -5 and 0. So we write that as an in-between statement like this. And then if you look, both of our points are closed, so we're including the values, All right, looking at the next piece, this is a downward-facing parabola. So for a downward-facing parabola, I know it starts off with, oh, and also if you look, it doesn't have a vertical stretch or a horizontal stretch, anything like that. But it is downward-facing, so it's going to be negative. And then we need to know what our vertex of that parabola is. And as you can see, it's 0, 3. So we're going to say x squared plus 3, negative x squared plus 3. And that's if, and if you look, that's in between 0 and 3. So in between 0 and 3. And then there's an open point at 0. There's an open point at 0, and it better be because this one was closed. And a closed point at 3. All right, so our last piece right here is this line. So we need the slope of the line, and we need the y-intercept of the line so we can write the equation of the line. So if you look, you can see the slope is up 3 over 1, so the slope is 3. The y-intercept, where it hits the y-axis, it's not physically hitting the y-axis because it's a piece of the line. So let's just continue the pattern to see where it would hit. So we're going to go down 3, left 1, down 3, left 1, down 3, 1, 2, 3, left 1. And it would hit at -7 if it continued. So this is the line, y equals 3x minus 7. And that starts at 3 and goes forever. So this is if your x values are greater than 3. All right, that's it for our notes on piecewise functions. You can go ahead and start the homework.